All right, 8th grade. So today we're talking about graphing a function rule. So things that we need to know. We need to know that a continuous graph is a graph that's unbroken, and a discrete graph is a graph composed of distinct isolated points, and we'll get more into that vocabulary later. Example 1, graphing a function rule. At this point, we are graphing using tables. I haven't showed you any tips or tricks. We are graphing using a table. So when we use a table, we have an X, we have Y. X is our domain, Y is our range, but really the other thing to think of is X is our input. So I'm going to do 3 points, -2, 0, and 2. And so to find my Y values, I substitute these X values into my equation. So here I have Y equals -2. I'm going to replace X with -2. And then I have +1. So -2 times -2 is 4. +1 is 5. So my point is -2, 5. So I can go ahead and plot that. So left 2, up 5, put a dot there. All right, and then I plug in 0. Y equals -2 times 0 plus 1. -2 times 0 is 0. Plus 1 is 1. And so 0, 1 is my next point. So 0, 1 right there. And then I plug into Y equals -2 times 2 plus 1. -2 times 2 is -4 plus 1 is -3. So we end up with a -3 here. So my point for this one is 2, -3. So I'm going to go to 2 and then down 1, 2, 3. All right, so that's where all my points are. And then to the best of your ability, if you have a straight edge, when you're doing this on Math Excel, you just pick 2 of your points and you graph it and you have a straight line. I always do 3 points, even though on Math Excel we just have to choose 2. I always put 3 because then I can use the 3rd point and make sure that it is on that line to make sure that I did all the calculations correctly. So that's just a way that I do to check myself. All right, so graphing real-world function rules. So we have that the function W equals 146C plus 30,000 represents the total weight, W, in pounds of a concrete mixer truck that carries C cubic feet of concrete. If the capacity of the truck is about 200 cubic feet, what is a reasonable graph for this function rule? Now, we are working with real world. We cannot have a weight that is a negative weight in this case. Like we can't have a negative weight, which is why I only have the first quadrant here, because I'm not going to have any negative, in this case, C values or any negative W values, because we also can't put in negative cubic feet. So we're working with all positive values. Our C is going to be our X value, so that's going to be, the X-axis is going to be our cubic feet of concrete. Okay, so this is our cubic feet. This is our capacity is what that is. And we're going to count this by 50s. So 50, 100, 150, and then here would be 200. All right, and then my Y value is going to be the weight. And I'm going to count those by 20,000s. Actually, I'm counting them by 10,000s, but every 2 I'm going to put what the 20,000 is. Oops. 60,000. All right, so that's how I'm setting up my graph. Now I did this ahead of time, which is why I knew I was going to count by those. But how we do this, we're still going to make a table, and I'm going to put in my capacity and then my weight. I'm going to count by 50s for my capacity, so 50, 100, 150, 200. When you're working with something like this and you're trying, like the reason we're stopping at 200 is it's telling us that the capacity is 200. Like we can't go beyond 200. And so it's better to count by something higher than 1. Otherwise, it's going to take us forever to get values, right? And then we're just going to plug them in. 146 times 50 plus 30,000. And when I plugged that into the computer calculator, I ended up with, oh, I guess I didn't mention 00. But when I plugged in 50, I got 37,300. And when I plug in 100, 146 times 100 plus 30,000, I end up with 44,600. And then 146 times 150 plus 30,000. These are all things that this is what I'm typing into the calculator. And so then that gives me 51,900. And then 146 times 200 plus 30,000. And that's going to give me 59,200. And then the one that I normally would have up here, but I forgot to put, is 0. And when I plug 0 in, 146 times 0 plus 30,000, I end up with 30,000. So starting there and graphing, 0 and then 30,000. So that's halfway between the 2 and the 4, or 20 and 40. And then 50 is at 37. So we're close to that 40,000. And then 100, we're at 44,600. So that's going to be halfway between the 40 and the 50, or approximately halfway in between. And then 150 was 51,000, so that's just above the 50,000. And then 200 is, oops, I put that one too close. That one should be here, not there. All right, and then the 200,000 is at 59,200. And so that's about here. And then we're going to draw a line through, but I shouldn't go past the 200. So I'm going to actually kind of come this way best I can, because 200 is the capacity. So I'm not going to have any values past that number. And the reason we draw a line is because if I were to add, figure out for 25,000, there is a weight for that one. So there's weights in between our numbers. Whereas if it didn't exist, like we're selling cookies, right? And you can't sell half a cookie, then we would just use dots, no line in between. So in the next video, we're going to do one more real world situation. And then what if we are graphing nonlinear functions? So that's going to be in the next video. See you there, 8th grade.